Hello students, good morning. Hello everybody, welcome back to my class. This is Pradip sir with a new session of quadratic equation from class 10 mathematics. Students, this quadratic equation you have done earlier also in the form of factorization and finding the value of x, but elaborate study was not done earlier. In lower classes you have factorized, you have found the values of x also, means values of the equation also, but the real meaning, the concept of quadratic equation was not in the detailed form. In class 10 we will learn about this quadratic equation. First of all, a quadratic equation is in x is an equation which is in the form ax square plus bx plus c equals to 0, where a, b and c are all real numbers and a not equals to 0. So let me write it. Quadratic equation in x is an equation of the form ax square plus bx plus c equals to 0, where a, b and c are real numbers and a not equals to 0. Okay, all the quadratic equation are in this form. The standard form of quadratic equation is ax square plus bx plus c equals to 0. Now if we change the variable, suppose in place of x, if you want to write y, no problem, you can write it. So in that case, the standard form of the quadratic equation will become a y square plus by plus c equals to 0. So this will be called as quadratic equation in y. Similarly, if you take the variable as t, so it will be ab square plus bt plus c equals to 0. This is also quadratic equation in t. Here also a, b and c are real numbers and a not equals to 0. Now why this one is called a not equals to 0? It is very clear that if we put a equals to 0, then this standard form will become bx plus c equals to 0, because a is 0. So if a is 0, then this will no longer remain a quadratic equation. Instead, it will become a linear equation in x. Okay, so that is why a can never be equals to 0. Understood? Okay. Now is the root of the quadratic equation. What do you mean by root of quadratic equation? A real number, suppose I am taking a real number alpha. A real number alpha is called the root of the quadratic equation ax square plus bx plus c equals to 0 if x is replaced by alpha, then it will become A alpha square plus B alpha plus C equals to 0. So if we put the value of alpha here and this quadratic equation satisfy this equation, that is both the LHS and RHS, that is left hand side and right hand side becomes equal. So we can say that alpha is the root of the quadratic equation. In very simple word, you all know how to find the value of x from this quadratic equation by factorizing it or by using the identities. So after factorizing it or using identities, you will get the values of x. Since it is quadratic equation, then you will get two real values of x generally, two real values of x, or different cases are also there where you will get non-real roots. So that is different thing, we will discuss about it later. So if we put the value of x, after solving this quadratic equation, you will get two values of x. Those two values are known as the roots of the equation. If the left hand side and right hand side becomes 0. Understood? Okay. So this is the root of the quadratic equation. So if any real value satisfy this equation, ax square plus bx plus c equals to 0. If any real value of x satisfy this equation, then that real value is known as the root of the equation. Or if that real value is the solution of the equation, then we will call that real value as the root of the equation. Understood? The solution is known as the root. Okay. So now let me explain you how to solve simple types of quadratic equation, either by using identities or just taking common factors. So here I am giving you the questions. Let me give some easy questions first. Okay, before that, first let me tell you which equations are quadratic and which are not. That is very important. Here x square minus 3x plus 3 equals to 0. We have to decide whether it is a quadratic equation or not. Now students, see, it can be written in the standard form. The standard form is ax square plus bx plus c equals to 0. Now if you compare this given quadratic equation with the standard form, here we will get a as 1, b as minus 3 and c as 3. So here this a, b and c all are real numbers and a is not equals to 0. So we can say that this given equation is a quadratic equation. Our condition says that a, b, c will be real number and a will not be equals to 0. So this condition is satisfied here in this equation. So it is a quadratic equation. The next one is 3x square minus 2 root x plus 8 equals to 0. The standard form is ax square plus bx plus c equals to 0. So if you see this equation and compare with the standard form, you will find that this is not in the standard form. This equation is not in the form of standard form, that is ax square plus bx plus c. Why? Because here the variable, the power of the variable is a fraction. Root x means x to the power 1 by 2. So for quadratic equation, the power of the variable cannot be fraction or decimal or negative also. So here it is fraction, the power of the variable is fraction. So we can say that this is not a quadratic equation. Okay. The next example is x plus 1 upon x equals to x square. X plus 1 upon x equals to x square. We have to decide whether it is a quadratic equation or not. So first of all, let me simplify this. Let me write in the standard form. So here x is the LCM, x square plus 1 equals to x square. By cross multiplication, x square plus 1 equals to x cube. So if x cube is brought to the left hand side, it will become x cube equals to x square plus 1. I have interchanged the sides, and then x cube minus x square minus 1 equals to 0. Right hand side is 0 now. Now compare with the general form, the standard form, or the general form. Is this equation is matching with this one? Of course not. Here the power of the variable is 3, but we have learned in case of quadratic equation the power of the variable should be 2 only. That is why it is known as quadratic. So it is not quadratic, actually it has become a cubic equation. Okay, so we will say that this is the given equation is not a quadratic equation. Understood? So now I hope that you have understood the difference between which equation is quadratic and which is not. Understood? Okay. Now one more example. Y square equals to root 2. Can we call this as, or y square equals to 2? Can we call this as quadratic equation in y? Y square equals to 2. Okay, let me check. So right hand side becomes 0. Now can we compare this with the general form? The general form is ay square plus by plus c equals to 0. This is quadratic equation in y. Can we write this in the general form? Yes, of course we can write it. So y square, since here the variable y is not there, so we can write 0y, because 0 is also a real number. The condition says that a, b and c must be real number and a not equals to 0. So here, since b is not there, we can write 0y, and c here it is minus 2. So if you compare with the general equation, then a is 1, b is 0 and c is minus 2. Therefore a, b and c all are real numbers and a is not equals to 0. So we can say that this is also a quadratic equation in y. Got it? Very good. So let us now discuss about few examples, very easy type examples. Three x square minus 243. We have to solve this. Find the roots. 3x square minus 243 equals to 0. We have to solve this. We have to find the roots of this quadratic equation. Okay. So here, first of all, we can see that 3 is the common factor of both the terms. Okay. So if 3 is taken common, then it will be x square minus 81 which implies 3 x square 81 can be written in the form 9 square equals to 0 or 3, this is in the form of the identity a square minus b square, that is a plus b multiplied with a minus b. So x plus 9 multiplied with x minus 9 equals to 0. Now students, as you can see, there are three factors, 3, x plus 9 and x minus 9, and the product of these three factors is 0. So we can say that either this one is equals to 0 or this one equals to 0. But can we say that 3 is equals to 0? Of course not. 3 can never be equal to 0. So only these two factors, x plus 9 and x minus 9, these two factors can be equals to 0. So we can say either x minus 9 equals to 0 or x plus 9 equals to 0. That is x equals to 9 or x equals to minus 9. So here we have got the roots as 9 and minus 9. So 9 and minus 9 is the root of this equation. It is also, these are also the solution of this quadratic equation. Understood? So what we have done here, by taking common and then by factorization using the identity. By using this method, we can easily solve this quadratic equation, find the roots. Okay. One more question. 2x square plus x minus 6 2x square plus x minus 6 equals to 0. 2x square plus x minus 6 equals to 0. So students, you can see that we cannot solve this by identity. So we have to use the technique of splitting the middle term. Okay, by using that method, splitting the middle term, we can easily solve this. So 2 will be multiplied with 6. As you all know, in the middle term, splitting the middle term method, we have to multiply the extremes. So 2 multiplied with 6 is 12. Now here the middle term is 1, means the coefficient of the middle term is 1. From 12 we have to make it 1. Now how can we make? If it is divided by 3, it becomes 4. So see here, 2x square plus this 1x can be written as 4x minus 3x minus 3 equals to 0. So this method I am not going for a detailed explanation because it is already done by you in class 8 and 9 also. Most of you know the method of splitting the middle term. So here the middle term is divided into two parts, 4x minus 3x, that makes 1x. So from these two terms we have to take common. So from 2x square and 4x, 2x is common. Then if there is x and here we will get 2. From 4x, 2x is taken common. So 2 will be left inside the bracket. Minus, here between these two, 3 is common. As you see, it is 3x and it is 6. So we can take 3 common. So it will be x. This minus will become plus because minus is already taken out. So it will become plus. From 6, 3 is taken as a factor, so another factor is 2 equals to 0. So here we are getting x plus 2 and 2x minus 3 equals to 0. Either x plus 2 equals to 0, which implies x equals to minus 2, or 2x minus 3 equals to 0, which implies 2x equals to 3 or x equals to 3 upon 2. Therefore, the roots are 3 upon 2 and minus 2. Hope we have understood. The method is very easy. Questions are also very simple type. We'll learn about some standard also. So that's all for today. Let us meet in the next class. Till then, goodbye and have a wonderful day.